few types of graph coloring problems. Vertex coloring. Good morning/afternoon, everyone. Today, I will explain a classic problem in graph theory known as the graph coloring problem. This problem plays a significant role in computer science, discrete mathematics, and real-life applications such as scheduling and resource allocation. What is the graph coloring problem? The graph coloring problem involves assigning colors to the vertices, or nodes, of a graph in such a way that no two adjacent vertices share the same color. Adjacent vertices are those connected by an edge. The goal is to use the minimum number of colors possible while maintaining this condition. This minimum number of colors needed to color a graph properly is called the chromatic number of the graph. Why is this important? Graph coloring is not just a theoretical exercise, it has many real-world applications. One classic example is exam scheduling. Imagine a university where several courses share common students. We want to schedule all exams so that no student has two exams at the same time. This can be modeled as a graph, where each course is a vertex. An edge connects two courses if they share at least one student, and each time slot is treated as a different color. A valid coloring ensures that no two connected courses are scheduled at the same time, and using fewer time slots means a more efficient schedule. Another example is frequency assignment in mobile networks, where nearby towers need different frequencies, colors, to avoid interference. Types of coloring. There are a few types of graph coloring problems. Vertex coloring, the most common type, where we color the vertices. Edge coloring. Here, edges are colored so that no two adjacent edges share the same color. Face coloring. In planar graphs, like maps, we color regions or faces. This is related to the famous four-color theorem, which states that any map can be colored with no more than 4 colors such that no neighboring regions have the same color. Solving the problem. There are various algorithms and approaches to solve the graph coloring problem. Some of them are greedy algorithm. This is a simple and fast method that assigns the first available color to each vertex. Backtracking, a more exhaustive approach that tries all possible colorings and backtracks when a conflict arises. Heuristic algorithms, such as desatter, degree of saturation, which chooses vertices based on how constrained they are. Meta-heuristics, like genetic algorithms and simulated annealing, used when the graph is large and finding an exact solution is difficult. Summary. To summarize the graph coloring problem, asks us to color the vertices of a graph so that no two adjacent ones share the same color, using the smallest number of colors possible. It's an NP-hard problem, meaning it's computationally challenging, especially for large and complex graphs. But it's also very useful in solving practical problems like scheduling, resource allocation, and network design. Thank you for listening.